Okay, YouTube, in this video we're going to introduce the concept of the unit circle. We're not going to do so in such detail that we memorize a lot of it, but just basically some simple facts, starting with the fact that our unit circle is a circle defined by the equation x squared plus y squared equals 1, and it has its center at 0, 0. So important facts about this are that it is located centered at the origin, but also that its radius length is 1, and we can see that in this diagram here. So with a radius like 1, the interesting thing is this: we say that the values of sine theta and cosine theta are simply the y coordinate and the x coordinate respectively of the point where the terminal side of theta intersects the unit circle. So looking at this unit circle, first of all, the unit circle, we use the prefix or the word unit to indicate that it has a radius equal to 1. That's what we mean by the unit circle. But what they're saying here, or what is being said here, is this point xy, where our angle here, our terminal ray goes out and intersects the unit circle, this point xy really represents the cosine of that angle and the sine of that angle respectively. And the reason why we arrive at this consequence is simply because knowing that we have the sine of theta with our new definition as being the y value of our point on the terminal side over the r value, and that the cosine of our theta here is really x value over the r value. When we substitute a 1 in for our radius, what we end up with is a statement here that says this. We say that the sine value is the y value and that the cosine value is the x value. So when we're dealing with a circle of radius 1, then all of the points on the outside really are telling us the cosine value and the sine value of that angle. So what I'd like to do in this video is use this to easily determine the trig function values of quadrantal angles. Now recall that when we refer to quadrantal angles, these are these angles that lie where the quadrants change. So we have 90, 180, 270, and 360 or 0. And that's in degrees. If we do this in radians, we would say that this is the same thing as pi halves radians. This is the same thing as a pi rotation. This is the same thing as a 3 pi halves rotation. And then this last one out here would be, I suppose, 0 or 2 pi. But regardless of whether we're doing this in degrees or radians, what I want to do is be able to maybe find the sine of 90 degrees or the cosine of 90 degrees or any of these trig functions of a 90-degree angle. And the way we could do this easily is to use the unit circle. So let's go ahead and take a look at this here. It says, let's find the 6 trig functions of the 90-degree angle here, or of a 90-degree angle here. But what I want to use is the unit circle. So the unit circle, what we're going to do first of all is we're going to make a sketch of our unit circle. And we know that the radius of the unit circle is 1. So the reason why this is convenient is because when we look at these 4 points around the outside, we can say that these are any points on this circle, not any points on the circle, but these are the points on this circle that lie on the axes. And so since the radius is 1, we can clearly see that this would be the point 1, 0. This would be the point 0, 1. Over here we'd have negative 1, 0. And we have the point 0, negative 1. So with respect to our unit circle, let's remember a few things here. We'll remember that the cosine and the sine are our x and y values of these points respectively. So when we talk about a 90-degree angle here, sine of 90, cosine of 90, what we'll do is we'll say, well, first of all, sketch the 90-degree angle. Here's our 90-degree angle. But what we're getting here is that we have the cosine of this function value, the cosine of 90 degrees and the sine of 90 degrees right there for us. So we say because on the unit circle the cosine value is the x value, then we'd say the cosine of 90 degrees is 0. Because on the unit circle the y value is the sine value of that angle, then the sine of 90 degrees is 1. And with respect to finding tangent, remember that we're saying that this is the y value over the x value here. So really what we'll do is we'll just take our 1 over our 0, and what we end up with here is something that we say is undefined. We cannot divide by 0. So with respect to finding the reciprocal functions, these would be the cosecant of 90 degrees. These would be the secant of 90 degrees, and also the cotangent of 90 degrees. What we end up with here is just the reciprocal of these original 3 values. So when you say the reciprocal of 1, remember that this is really the same thing as 1 over 1. And so the reciprocal of 1 is really just 1 over 1, or 1. Now on the other hand, when we say 0, we really mean the same thing as 0 divided by any constant that's not 0. I'm going to use a 1 here, but when you reciprocate this 1 over 0, we end up with something that is undefined. And then with respect to our tangent value, which was initially undefined, when you flip over the undefined here, we get 0 over 1, which in this case is 0. So one thing that needs to be mentioned here in this video is simply this. We would say that the reciprocal of something that's undefined is 0, and the reciprocal of something that's 0 is undefined. Also, lastly, that for any quadrantal angle, it's really just easy to sketch that angle in standard position, like a 180 here would be facing this direction, but also to go ahead and impose the unit circle around the outside and say, look, we know these 4 values right here, and if we're looking at a 180, we would say that its cosine would be -1, its sine would be 0, its tangent would be 0 divided by -1, and using those 3 original relationships there, we could go turn all those over and find the reciprocal functions of 90, or 180, or 270, or 360. Cheers.